Retrieval augmented generation with LLAMA.CPP. This is the scope of this video. Large language models are parameterized models. What it means is these models are fed with billions of parameters or sequence of data, and they are able to learn the language of forming sentences and all the other cool stuff that the LLMs are capable of doing. But one drawback on these large language models is that they are trained at a given time, and there is no new knowledge that can be available in these large language models. So, for example, if you are querying a ChatGPT past 2021, it says I don't find data. But if you have a means of taking new data and not go through that entire training process, but be able to somehow feed this data as prompts to the large language model, and then whereby utilize the capabilities of the large language model to understand the new data, then I think it will serve our purpose. So in this video, I'm going to show how you can use the retrieval augmented generation with LLAMA.CPP. We have quite a few examples out there on the YouTube with just the Llama model that has been quantized using the Hugging Face interface. However, the LLAMA.CPP is something that you probably will learn new today. So let's quickly go back and see what are the steps involved here. So what are the steps involved to create a retrieval augmented generation pipeline based on your custom data? So the first thing that you need to do is to instantiate an embedded model as a means to vectorize your custom data. What does this mean? So you have your custom data that's sitting somewhere. It might be on your hard drive. It might be it might be a website. It could be Wikipedia. It could be whatever, right? It's your custom content, and you think that that data doesn't exist in your large language model. So you need to take this data and then you need to vectorize it. But to vectorize it, there are language models out there. They are called sentence transformers. I'm sorry, they're not language models, but they're called sentence transformers that take sentences, that take large corpus of data and then vectorize it. In this case, we'll have to choose some sort of a model, and I will show you what it would be. The next step is to pre-process your data into custom into chunks. So you take your data and then you use some sort of a Python library, pandas or whatever, to pre-process your textual data into some sort of a JSON object with equal chunks. And then you store this custom content into the vector database. And before you do that, you say that, hey, this is my chunk of data, and this is the embedded model that I would want to use. And the magic happens behind the scenes. It takes all your chunk data and it will store it as vector data of a predefined dimension space. For example, you have some sentence transformers that have, I believe, 384 dimensions, and that's what we probably are using here. So now you have your data in your vector database. So once you have that, now you are ready to instantiate your LLAMA.CPP model, which is your parameterized model, right? And if you look at my previous video, I show you how to take Llama 2 model, convert that to LLAMA.CPP from scratch, and then quantize it to a 4-bit integer quantized model. So you instantiate your LLAMA.CPP. The next thing is that you are now ready to query your LLAMA.CPP with your vectorized data. For that, now you probably have injected quite a bit of data into your vector database by pre-processing your data and storing it. Now your query might be asking some specific part of that custom content. So you write your query and then you do a similarity search on your vector database by retrieving only that subset of your custom content. And that's your step 5. And once you get your retrieved documents, that subset of your custom content, take your query along with your retrieved documents and go to the parameterized large language model by creating a pipeline. And final step would be to query the pipeline, basically the query that you are sending it through the pipeline, and your large language model is going to come back and process your custom data, your query based on that custom data, and give you a means to talk to your own data. So let's see how this is all done in a Python notebook, in a Jupyter notebook. The link to this notebook is provided in the comment section, so you can feel free to go to my GitHub and download this notebook. As we have talked earlier, there are a few steps to get RAG pipeline working on LLAMA.CPP. The first thing that you need to have is a reference embedded model, which is in this case I have referring to a sentence transformer from Hugging Face. Please look at this and read about it. It, I believe, generates a 384 or so dimensional data for whatever custom content you provide. So the first thing that I do is I instantiate that embed model. The next step is to go to my custom content, and this content can be on your local drive, it can be a website, it can be Wikipedia, it can be whatever. Here I'm loading some content from quadratics.com, MLOps-simplified.html. So as you can see here, this is a simple data here that is not available in the large language model. I mean, nobody knows about it. It's a company that does very specific work on AI and MLOps and data analytics. So I just use that as a reference to query my RAG pipeline. So that being said, we'll go back to the second step here, which is it loads the data, creates a chunks of data, and then stores everything into this variable called all splits. Now we take this data that's chunked into this variable called all splits into a vector store. And in this case, the vector store is Chroma. And what we have done is we have taken all of my documents that are in chunks and storing it into Chroma database based off of the embedded model that we instantiated in step number 1. Okay. So now you have your data stored into your vector database. And the fourth step is now to take our LLAMA.CPP model that we quantized in the earlier step. In our earlier video, I have shown you how to quantize this LLAMA model into LLAMA.CPP and then quantize it. So now we are actually referring to that particular model in this step 4, and we are loading it and passing a bunch of parameters with regards to what that would be. So let me run each of these steps here. So now we are storing, third step we are storing, and the fourth step we are instantiating the model. And once you instantiate, it kind of says that, hey, I'm using the model size 7B, and then I'm using number of layers 32. I'm loading maximum 32 layers into the GPU and what have you. So now you have instantiated your LLAMA.CPP model. You have your custom content into the vector store. Now let us see how we are going to create a RAG pipeline. But before we do the pipeline, we would want to ask a question to our vector store so that it goes back to the vector store and retrieves documents that are pretty much similar to what our question is going to be. So in this case, we are asking what accelerators did Quadratic build? And obviously this question, it doesn't exist with the current LLMs. So now we have created a set of documents, and then you can also see, if I go and print this document, you will see that these documents are pretty much, it's giving content based on the website that you are seeing here, right? So because it's already stored in your database, in your vector database, that's the content it gave back to you. And the next thing that we do is we take the docs that are a subset of the actual custom content we have on Quadratics website, and then we are passing it into something called a pipeline. And here we use Retrieval QA from LangChain, and this is the one that builds your large language model chain along with your RAG. So we are passing the normal LLM that was instantiated. We are saying the chain type equals stuff, and I think you can look it up what it means. And the retriever would be the vector store as retriever, which is essentially what we have got from a context standpoint here. So once you execute this, You created your rack pipeline. So rack pipeline is pretty much a variable very similar to your LLM, but now it has a better context with your data. So now if I go and do a query here, what accelerators, I'm sorry. That's a typo there. So now it is coming back with an answer. Quadratic built a set of accelerators for enabling ML AI model lifecycle as an MLOps suite, and that is available only here. It's not available anywhere else. And it did it did actually build some sort of a textual content. And now you can also ask more questions here, right? What accelerator? So how did how do the accelerators built by Quadratic help their customers? This is purely English language, right? So it now comes back and says accelerators created by Quadratic enables. So it is able to not only rewrite what exactly is there, but it is actually looking at the customer that we are saying that it is going to help, but then completely reform that sentence in a very readable English format, which is what we are really trying to find here. Now on the final token, just to show you, if I go back to the original LLM that was not trained on this custom data, and you ask the same question, it's going to come back and says nobody knows when it, so this is all garbage, right? I mean, we know that this is not what we are really trying to look at. So in this video, what you have seen is you can take your custom data, map it on top of your large language model, create a RAG pipeline, start querying your data. Very easy. Thank you guys.